Hello everyone, this is Geethapriya from RMD Engineering College. In this lecture, we will be seeing about classical TCP improvement for wireless communication. So, three improved TCP versions will be discussed here. The first one is indirect TCP, snooping TCP, and mobile TCP. So, mobile TCP is the one which is currently used for all the mobile phones. So, the first one, indirect TCP. Here, the whole connections or whole operation will be divided into two parts. The first one is from the correspondent host. So this will be called as a correspondent host or a sender, and this is a mobile host or the receiver. So from the correspondent host, that will be communicating with the access point. Access point is also called as a foreign agent. So from the sender, that is your correspondent host, to the access point, it is via the internet. That means your old TCP connection. So normal TCP or standard TCP connection has been established between the sender and the access point. From the access point to the mobile host, the wireless TCP has been implemented. So how the communication happens here means the sender will be sending the information that will be received by the foreign agent. There is no direct connection between sender and receiver here. The sender will send the information to the access point, and access point is going to send the data to the mobile host. So whatever information is sent from the sender, it is received by the access point, and this access point will be having a buffer. So in this buffer, all the information that has been received from the sender has been saved in the access point buffer. So in TCP, we know that it is once a message has been sent, immediately acknowledgement will be sent by the receiver, acknowledging that the information has been received. Once the acknowledgement has been received by the sender, the next information will be sent to the receiver. So once the access point received the message from the sender, it will send the acknowledgement to the sender. The sent information or received information will be stored in the buffer. From the buffer, it will be sending the information to the receiver, that is your mobile host. So after sending the acknowledgement, it will be sending the information that is stored in the buffer to the receiver. So if suppose mobile host has not received the information that is sent by the access point, no acknowledgement will be sent by the mobile host to the access point. So in that time, access point will resend the information to the receiver. That is the information stored in the buffer will be there. So once the acknowledgement is not received by the access point, it will resend the information to the mobile host. So after some point of time, the buffer, the information stored in the buffer will be deleted. It is a temporary memory, and temporarily the data has been stored. Once the information is sent to the receiver and acknowledgement is received back, you can go with deletion of the information also. So this is how indirect TCP works. The next one, snooping TCP. This is similar to indirect TCP, but one improvement from indirect TCP to snooping TCP is there is a direct connection between the correspondent host and the mobile host. That is, a direct connection has been established between the sender and the receiver. Also, a foreign agent or access point will be present here. So to go with the workflow of snooping TCP, the correspondent host is connected to the foreign agent via the internet, that is via the TCP or the standard TCP, and from the access point to the mobile host, it is same as indirect, which is wireless TCP. So once information is sent by correspondent host, that will be directly sent to the mobile host, and also the information is stored in the access point also. So whenever an acknowledgement is not received back from the mobile host, the foreign agent or access point will retransmit the data to the mobile host. So the receiver don't want to reside on the sender to retransmit. Instead of that, the access point itself resend the information to the mobile host. So here the job of access point is to store whatever information is sent from sender to receiver, and have to check or you have to snoop on acknowledgement that is sent from receiver to the sender. So once the acknowledgement is not received from the mobile host, the foreign agent will retransmit the data to the mobile host. So this is called this is the workflow of snooping TCP. The last one, mobile TCP. So here this is also similar to the previous two thing, but here the same connection, the standard TCP between correspondent host and the, here we will be calling the access point as supervisor host, and wireless TCP between supervisor host and the mobile host. Why access point is called as supervised host in mobile TCP? Because here there is going to be no buffer and it is going to just monitor what are the operations are done from receiver to sender or sender to the receiver. So the sender and receiver can communicate directly. So sender is going to send some data to the mobile TCP mobile host by using end-to-end TCP connection, and mobile host once receive the information, it will be sending the acknowledgement back to the sending host. Suppose an acknowledgement is not received from the mobile host, so this supervisor host will be monitoring all those transactions. So once the acknowledgement is not received, the supervisor host will forcefully stop the correspondent host to stop sending the next data. So one and only if acknowledgement is received from the mobile host, supervisor host will allow the sender to send the next information. So this is the workflow of mobile TCP. So in this lecture we saw 3 TCP, which is the improved version of TCP. Thank you.